I am Devaki, Assistant Professor EC at the College of K.S. Rangasamy College of Technology. Today I am going to say about session about the module or microprocessor and microcontroller. The name is time delay and counters. Before we are going to see about the time delay and counter, we have to know that what are the machine cycles available in 8085 microprocessor, how many T state required for this each machine cycles. Okay, so in 808 microprocessor have a 8 data bus, 16 address lines are there. So in 8085 microprocessor has a 5 basic machine cycles. So what are they? Opcode switch, memory read, memory write, input output read and write signals. So for opcode fetch we have to need the 4 T state, required 4 T state. Memory read and memory write is required 3 T state. So input output read and cycle required 3 T state. Okay. So then we have to see about the status signals about 8085 microprocessor. So this is the status signals of 8085 microprocessor. The status signals, the first one is the input output bar memory S1 S0. So we need to access the input outputs. We have to connect with the external peripherals. We have to need to access the input output. We have to access the memory. M bar. We have to access the memory. Okay. S1 S0 is the status signal. So it's we have to access the external device with 8085. Have to enable the pin as set as 1. In case of 0, it's default. It's default is directly access the memory. So in case of S1 S0, the both are 1. It's a machine is a opcode switch. 10 it's a memory read. 01 is a memory write. So in case of you have to access the external device, the input output pin is set as a 1. So 10 is the input output read, 01 is the input output write, 11 is the interrupt acknowledgement. Okay, this is the timing diagram for STA 526AH. So H is the hexadecimal. So what is the meaning of this STA 526A is the accumulator content is stored to the concerned memory locations 526A. 526A is a memory, H is a hexadecimal. This is the timing diagram for STA 526A. Okay. The first one, what do you mean by T state? T state is nothing but it's a clock signal. Okay, we have to access the single instructions. How many T states are required to execute the single instructions? In case of STA 526AH, it's the content of accumulator value stored to the 526A address. Okay, so first one we have to fetch the opcode. Next one we have to move the data into the higher order bus, higher order address as well as lower order address. Then data moved to the concerned address. Okay, so we have to need to the data move on to the concerned higher order, lower order. So we have to access the double memory read. Okay, next one is the memory write. This is the clock signal. Okay, this is the clock signal. For in case of the first one is the AD0 to AD7. It's a multiplex with the address lines as well as data lines. So AD0 to AD7, it's a lower bit address data bus. D0 to D7 in 8085 has a 8-bit data bus. Next one is a higher order address A8 to A50. Okay, the first one we want to move the program which continue with 41FF. 41FF in case of 8085, 41FF we want to store the opcode of 32. Okay, so 41 is indicate a higher bit, FF is a lower bit. So 41FF. So 41 we have to access the memory 41FF. We want to move the 32 opcode to the concerned address 41FF. 32 is the opcode which is notify the STA. Okay. Next one is the 4200. 40 is a higher order byte, 00 is a lower order bit. 6A is a lower order address. The lower order address it's a transfer to 4200. Next one is a 4201. Next consecutive address Phi 2 is the higher order address. Higher order address move on to the 4201. Okay, next one is the 526A. This is the address. Store the accumulator value. Store the accumulator value to the 526A address. Okay, so 526A is the address. The C7 data is move on to the 526A. Okay, this is a function of address and data bus. Next one is the ALE. ALE is doesn't mean that address latch enable. Once the address latch enable, it's switched on. The address and the data bus are demultiplexed. Okay, demultiplexed, that means they have to segregate the address by data bus. After that only the data it's move on to the concerned address. Okay, so address latch enables for every machine cycles. Next one is the read operations. We want to opcode switch 32 is move on to the 41FF. Next one is a 6A is lower bit address move on to 4200, higher bit address move on to 4201. This is a memory read. Then memory write. Memory write is a C7 is the data move on to the 526A. Okay, this is the memory write. So read and write operation, this is the inverse operations. So we have to down. It's mark the down. Okay, next one is the status signals. So in case of status signal, it's only to store the accumulator value to the content memory. Okay, so no need to access the input output device. So input output then memory access is always 0. Status signal is 0 1 for memory read, 0 1 for memory read, 1 0 for memory write, 1 1 for opcode switch. This is the timing diagram of STA 526A. So we have to require we want to access this particular instructions. We have to need the 13 T cycles for to execute the single mnemonics. Okay. So next we want to move on to see about counters and time delays. Okay. Counter is designed simply by the loading the appropriate number into the one of the register and by using increment decrement register. Okay. Loop has to be established within the program. The loop is the concern status is concerned. Whether it has reached the final number, the loop will be repeated. If not, it's exit from the loop. Okay. Next one is the time delay. Time delay which has used to have to delay calculation for entire program. Okay. This is the specific delay. It's load to the by the register loaded with a number depending on the time delay required to then register is decremented until reaches still 0. It reaches still 0. It's exit from the loop. Next one is this is the sample program to find out the counters and time delay. This is the sample program. First one is the move immediate C, FF. Next one is the decrement C, jump on no 0. It's exit loop. Okay. So FF data will be immediately move to the concerned register C. Next one decrement C, it's decrement C, it's a decrement the data by 1 by 1. So until it reaches 0. If not, its loop will be repeated. Okay. From move immediate C, FF, it's have a required T state is 7. Because of opcode fetch is 4, memory read is 3. 4 plus 3 is 7. Decrement C, it's required only opcode switch. Okay, it's need to access opcode switch. Need to access T state is a 4. Jump on no 0. Within the loop, it's execute the 10 stated. It's if its condition is satisfied, it's exit from the program. It access 7. Okay, this is the T states of particular program. Its clock frequency is given 2 MHz. So from the clock frequency, we have to find out the clock period. 1 by T equal to clock period. 2 MHz 1 by T 2 MHz equal to 0.5 microseconds. 0.5 microseconds is to execute the single T state. For in case of move immediate, we want to execute the single instructions move immediate C, FF. It's required 7 T state into 0.5 3.5 microseconds. Okay. Then next one is a time delay for entire loop. We want to access 4 plus 10 is a 14 T state into time delay 0.5 microseconds into 255. 255 it means that we want to the data is a FF. FF is a hexadecimal. It represented by decimal 255. Okay, 2 to 55 times the loop will be executed. Okay, the total time required is 1785 microseconds. its nearest value is 1.8 milliseconds. Okay, so we want to, from this loop, jump on no eject, it's carrying 10 t state, but we have to exit from the program. It's required is 7 t state, so it's required 3 t states, one it's extra we had added. So we want to find out the exact time delay, so we have to minus the 3 t state. This is the adjustable time required of loop instruction. 3L minus 3 t state into clock period, 1785 minus 3 into 0.5, 1.5 microseconds. So we want to execute the entire program by 5 time delay of 1783.5 microseconds. Okay, this is the sample program. Next one is we want to execute the single loop as well as double loop. For in case of single loop, LXI B2384, it's a LXI is a track load BC with a 16-bit counter. Okay, data will be moved to the concerned BC register pair, decrement BC, then move A comma C. C content is moved to the A. Its XOR operate with B. It's repeated until 0. Jump on no 0. It's execute decrement B. Okay, this is the number of t state required for each instruction. LXI for 10, decrement B is for 6 because of it's a decrement the register pair. Okay, so we need to access the 6 t state. For register single register decrement register B, it's carried out 4 t state, but in case of pair we have to need 6 t state. Then this is the 4 XOR with is only it's have a opcode fetch. It's have a opcode fetch. Next one is jump on no 0. So within the loop it's a carry 10. Exit from the loop carry 7. Okay, so time delay for entire loop t equal to number of t state 6 plus 4 plus 4 plus 10. It's 24 t state into 0.5 because of the frequency is 12 megahertz. 2384 is a data. Is hexadecimal data. It convert to the decimal value 9092. Okay, so multiply with all aspects 109 milliseconds. Okay, it's a 3 test is 109 microseconds. Next one is the milliseconds. Next one is the time delay using loop within the loop. Okay, we have to consider the double loop. Move immediately B comma 38, move immediately C comma FF. This loop is already we have seen about first program. So move immediately C comma FF, decrement C, jump on no carry within the loop 1. Next decrement B, jump on no 0, loop 2. Okay, only the difference one is move immediately B, it still reaches 0, the loop will be executed. So already from the loop move immediately C comma FF, decrement C, jump on no, it's already 1783 microseconds. Time execute for these instructions 1783. So only we have to add the remaining loop. Okay, 30 we have to move immediately B comma 38. 38 still the loop will be executed, still it reaches 0. Once it reaches 0, it exit from the loop. 38 is a hexadecimal value. It's convert to the decimal value. Decimal value it's a 56. Okay, so 0.5 into 21 plus t time delay. So 1783 into 56. We have to go into this is 100.46 millisecond to execute the is the time execute for the entire program. Okay, thank you. Taran.